In Cycle 2, Lesson 8, we're going to look at multiplying polynomials. Again, this is something that you've done before. You learned about this way back in grade 9, but as always, as we get to the higher grades, we sort of extend things a bit, and so probably maybe work with some higher exponents and things like that. Maybe not, but it should be a lot of review, which is always nice, rather than having to learn something brand new, at least as far as difficulty goes. So we need to know about the distributive, can't even say it, the distributive property. It says that when you multiply something in brackets by a single term, you should multiply each part in the bracket by the same term. So you just have to be really careful to simplify signs and to use the exponent rules, which you hopefully remember somewhat from previous grades. So let's just jump into some examples. So if I'm using distributive property here, I'm going to multiply 2x cubed times 3x, and I'm going to multiply 2x cubed times negative 4. So I don't usually write it this way, but I'm going to write it this way for this one, just so we can be absolutely clear. What I'm doing is I'm doing 2x cubed times 3x, and I'm doing 2x cubed times negative 4. Often I just do this in my head, right? But it's just good to see it at least one time. And then we multiply the coefficients times the coefficients. So 2x times 3 gives me 6. And x cubed times x, remember your exponent laws. So this is assumed to be an exponent 1 on that x inside the brackets, right? And so exponent laws tell me that when I multiply powers, I'm going to add the exponents together. I got x to the 4 from that part of the multiplication. Then I'll go on and I'll do coefficient times, in this case, a constant term, and it's a positive times a negative in this case. So again, we have to think about signs. 2 times negative 4 is negative 8. And then I've got this x cubed, and I don't have anything to multiply it by, so it just stays as x cubed. So again, the colors are just meant to show what I'm multiplying together in this case. Don't let them distract you. The final answer is 6x to the 4 minus 8x cubed. So I'm always just going to be multiplying whatever's in front by each term inside the brackets. So in this case, it's going to be negative 3x to the 4 times 4x squared. I'll do them one at a time in this case, and I won't write out. I'll do it in my head, so to speak. But I'll talk it out. Negative 3 times positive 4 is negative 12. X to the 4 times x squared, I add the exponents and get x to the 6. Then I go on to the next multiplication. I do negative 3x to the 4 times negative 2x. So negative 3 times negative 2, negative times negative gives me a positive 4. I'm multiplying these two things together, right? So negative 3 times negative 2 gives me positive 6. X to the 4 times x, which is assumed to be x to the 1, becomes x to the 5. And then I move on to the next one. Negative 3x to the 4 times positive 3 is negative 9. And again, I don't have anything to multiply that x to the 4 by, so it just stays as x to the 4. Hopefully that's familiar to you because, it's definitely something you've done back in earlier grades. Now this question here is just combining a couple of things. As in all things in math, we have to follow order of operations. So I've got really two parts to this. I've got this part and I've got this part. I need to do the distributive law first because that's multiplication, and afterwards I'm going to collect my like terms. Okay? So doing distributive law, I'm going to do 3 times x squared, which gives me 3x squared. I'm going to do 3 times negative 4x cubed. So 3 times negative 4 is negative 12, and I've got x cubed still. So both of those came from that first bracket. And then I'm going to do negative 2x times 3x squared. Negative 2 times 3 is negative 6. X times x squared, if I add the exponents, I get 3. And then I'm going to do negative 2x times negative 5x. Negative 2 times negative 5 is positive 10. X times x is x squared. So those are my terms and where they came from. I just highlighted them so you could see where they came from. But maybe I'll get rid of this highlighting if I can. So that I can then do some different highlighting where I'm going to show where I'm going to bring things together. So maybe I'll show that I got 3x squared and I got 10x squared. I've got negative 12x cubed and negative 6x cubed. So again, I'm going to put my like terms together, and again, I'm going to start with my highest exponent. And I'm moving the signs with the numbers. So negative 12x cubed minus 6x cubed, the purple ones I put first. Then I'm going to go back to my x squared, so 3x squared plus 10x squared. And when I add together my terms, the exponents don't change again. It's just how many I have. I've got negative 12x cubes. And then I'm subtracting 6x cubes from that, so now it's negative 18x cubes. They remain as x cubes, though. I've got 3x squared, so I'm adding 10 more x squareds to it. That gives me 13x squareds. And again, I'm down to something that they're not like terms, so I'm just going to leave it at that. If I try to go any further, I'm absolutely breaking the rules of math. I can't go any farther with this as it stands. The degree of a polynomial, just a reminder of this, again, back to grade 9, we learned this earlier. The degree of a polynomial is the value of the highest exponent. So what's the degree of each answer in example 1? So since I put them in order from highest to lowest, that makes it easy. The degree is just the exponent of my first term, since my first term's always got the highest exponent. So the degree for example 1 is 4. The degree for example 2 is 6. And the degree for example part C is 3. So again, the coefficients have got nothing to do with it. It's the highest exponent, which should always be your first term if you write them in the correct order. You can also use the distributive law to multiply terms in brackets by a polynomial with more than one term, so a binomial, trinomial, etc., using a FOIL process. So, for example, we know how FOIL works, right? Let me just do a little rough thing over here. FOIL, if I was doing FOIL, I would have, let's say I had A plus B times C plus D. FOIL tells me do first times first, outside times outside, inside times inside, and last times last. That's what FOIL stands for. And it's just telling me that I'm doing multiplications. You can see I'm doing 4 separate multiplications when I do FOIL. All I'm going to do in this from here on out is I'm going to extend that. I can't call it FOIL anymore because I'm going to have more multiplications. I'm actually going to have 6 multiplications going on in this case because I'm going to multiply each term in the second bracket by x squared. So there's 3 multiplications that are going to take place there. And then I'm going to multiply each of those 3 terms in the second bracket again, this time by negative 2. So if I stick to the color of the pen, then x squared times x squared gives me x to the 4. X squared times negative 2x gives me negative 2x cubed. Again, x squared times x is x cubed. If I do x squared times 3, well, then I get 3x squared. And so I just use the red pen there to match up with my red arrows. Now I'm moving on to multiplying everything by negative 2, representing it with the blue arrows. And so negative 2 times x squared is going to be negative 2x squared. Negative 2 times negative 2x is going to be positive 4x. And negative 2 times positive 3 is negative 6. And again, just using the light blue pen to match up with those multiplications. But really, there doesn't matter what color the pen is. I need to collect my like terms. So I've got x to the 4 term, but that's the only one I have of that. I've got an x cubed term, but I've only got one of those. I've got 2 x squared terms. I've got 1 x term, and I've got one constant term. So really I only need to combine these two middle ones, and they're already actually, just by luck, in the correct order. So I don't need to rearrange anything. I just have to recognize that those two middle terms can be combined. 3x squared taking away 2x squared just leaves me with 1x squared, which I could just write as x squared without the 1 out front. And there's my solution. So it's just like doing FOIL, except that there's more multiplications going on here. If you've got one that's, again, got multiple things going on, then we should do them in order. So I can just do FOIL on this part. And I could do FOIL on this part as well, but there's a 2 out front. So I'm going to tell you what not to do. So again, I'm putting the emphasis on not. Don't do distributive law, where I multiply each of these by 2 and each of these by 2. Do not do that. Are we clear? Do not. When it's multiplication, if I multiply each of these terms by the 2 out front, then I'm actually using this 2 more times than I need to. It'd be like, say I asked you to multiply 2 times 3 times 4 together. You know that 2 times 3 is 6, and 6 times 4 is 24. Multiplying what I just showed a minute ago, everything by 2, would be like doing 2 times 3 and then 2 times 4. So 2 times 3 is 6, and then 2 times 4 is 8, and then multiplying it together, and I'd get 48. That doesn't make sense. So I don't want to use that first number too many times. So there's a couple ways around it. The one that I would probably do is I just multiply the first term by 2 and then do FOIL. So I might just rewrite the whole thing down again, although there's different ways of writing it. But if I just multiply the first bracket by 2, then I'd have 2x squared minus 4, and then I could do FOIL. So again, the highlighting is just to show where things are coming from. You know FOIL, hopefully at this point, so you know you'll get x squared minus 3x plus 1x minus 3. That comes from doing FOIL on those first brackets. There's a minus sign here. I've really got to watch out for minus signs, right? I put the 2 inside the brackets, but I left the minus sign out there. So I'm going to keep the minus sign there, but we know that minus signs change all the signs of things. So I'm going to keep the minus sign there, but I'm going to put my answers to the second multiplication in brackets so that I can then worry about the signs later. So if I do FOIL on these second brackets, 2x times x is 2x squared. 2x times 3 is 6x. Negative 4 times x is negative 4x, and negative 12 is what I get from negative 4 times 3. Okay, collect my like terms in the first set. I've got x squared minus 2x when I combine these two like terms. Now, again, I have to deal with this minus sign. Remember what it does? Changes all the signs. So this is going to become a minus 2x squared when I take off the brackets. I could combine these maybe at the same time. That becomes 2x when I combine those two. But then when I change the sign, take off the brackets, it becomes minus 2x. And then this becomes a plus 12 when I give that the opposite sign, again due to that minus sign in the middle. You don't have to write them out in the exact same order I did, but you have to be very careful about your signs, and you have to collect your like terms. Now again, I got more like terms to collect. I'll just highlight them here for simplicity's sake. So I got x squared terms, I've got x terms, I've got constant terms. I'm going to start with the highest, which is x squared terms, and put them together. Then I'm going to do my x terms. And again, I'm moving the signs with the numbers that come after them. So I've got a couple of x terms next. Then I'll do my constant terms. And I've got it looking like this. And that gives me x squared minus 2x squared gives me minus x squared. Negative 2x minus 2x is minus 4x. And negative 3 plus 12 is 9. So it all simplifies down to that quadratic there. And I guess just one last thing for today. What does x squared plus 1 actually mean? Well, first I'll tell you what it doesn't mean, what I often see people write. X squared plus 1 squared, well, that must equal x squared plus 1, right? In the same way that x plus 2 squared must equal x squared plus 4. Wrong, wrong. We don't square each part inside the bracket separately. This squared is beside the bracket. Remember, exponents are on what they're immediately beside. This exponent is immediately beside the bracket. So what it actually means is x plus 1 times x plus 1. So I actually have to do FOIL to expand this out. This is going to do 4 separate multiplications. And so I'll get x squared plus 1x plus 1x plus 1. And so the actual answer is a trinomial, x squared plus 2x plus 1. So don't give me the ones I crossed out, because I always get people who do that. But those of you who know better will now know to do FOIL on something like that.